Hey gang, Dr. G here, Imaginarium. Got Mysteries of the Psyche for you today. So, you've heard it all before. At some point or another, somebody asking, is something a rather nature or is it nurture? Is it biological or is it learned? So, I would love to put this to rest forever. So, toward that end, I'm going to share with you some quotes. In 1958, Donald Hebb, widely considered to be the father of modern neuropsychology, put it this way, and I'll read you the quote here. Sometimes it's recognized that hereditary and environment both affect intelligence, but the writer then goes on to say how much each is. A student may find it said, for example, that 80% of intelligence is determined by heredity, whereas 20% by the environment. This statement is, on the face of it, nonsense. It means that somebody would have 80% of the problem solving he would have otherwise if he were never given the opportunity to learn a language or learn how people behave and so forth. On the other hand, it means 20% of their problem-solving capacity would result from a good environment, no matter how much hereditary is involved, which we know is, of course, not true. What we must say is that both of these variables are of 100% importance. Their relation is not additive, but multiplicative. To ask how much heredity contributes to intelligence is like asking how much the width of a field contributes to its area. Okay, keep that in mind. I think it's a really good quote, and it's more and more relevant now. My next quote is going to be Eric Kandel. He's a Nobel laureate, smart guy. 1998, his work on the neuroscience of memory and learning and its application in things like psychology and psychotherapy. Very important figure, and this quote gets quoted quite a bit in the literature, and it's great up until the last couple of sentences. Okay, so listen to this. Insofar as psychotherapy or counseling is effective and produces long-term changes in behavior, it presumably does so through learning, by producing changes in gene expression that later strengthen the synaptic connections and structural changes that alter the anatomical patterns of interconnections between nerve cells in the brain. Okay, so far so good. The regulation of gene expression, he goes on, by social factors makes all bodily functions, including the functions of the brain, susceptible to social influences. Okay, sure. Bodily functions are susceptible to social influences, biopsychosocial. Absolutely. These social influences will be biologically incorporated into the altered expressions of specific genes in specific nerve cells and specific regions of the brain. Yes, that's true. And we'll get into some of those here in a minute. These socially influenced alterations are transmitted culturally. Okay, where are you going with this? They are not incorporated into the sperm and egg and therefore are not transmitted genetically. Okay, so technically, yes, all of this is true. However, that last sentence, that cultural influences are not transmitted genetically, is extremely misleading. And you may not notice why right away, but I'm going to help you with that because it's something that really gets on my nerves. So let me give you a modern example of what I'm talking about here. This is since Kandel wrote that, we've gained a huge amount of knowledge about epigenetic changes in the genome of particular neural regions of the brain as it relates to psychotherapy, psychology, and so forth. A lot of this comes from rodent studies because you can actually measure the gene products in the brains of rodents. You can't really do that in humans. However, there's a lot of similarities in the regions that they're studying between rats and humans, and so we can make a lot of inferences, but I'll get to that. But, okay, so in rat pups, during the first week of age, if the mother of the rat pup licks the rat pup a lot, this stimulates their little rat brains, baby rat brains, to produce more serotonin, which then get picked up in the hippocampus. From there, the hippocampal cells stimulate a cascade of intracellular effects that lead to higher levels of a couple of different specific proteins like Krebs binding protein and NGF-IA protein. This leads to DNA methylation changes, which then leads to an increase in glucocorticoid receptors, which then affect the hypothalamus pituitary adrenal axis responses to stress. Did you get all that? Okay. Let me break it down for you for a second here. But bottom line is, with increased levels of maternal care and attention, measured by licking, which they do, it's grooming behavior in rats, this leads to epigenetic brain changes in the hippocampus of the rat pups that lead to long-standing changes in their stress response. Those that are groomed a lot compared to those that are not groomed will have more exploratory behavior. They have a lower startle response. They have less sensitivity to fear, and so forth. The rat moms that don't lick their pups, on the other hand, those rat pups, and this is within a week window, it doesn't seem to matter much after the first week. Within that week window, if they don't get very much licking, then they will have much higher startle response, much more reluctant to explore, much greater stress sensitivity, and this is lifelong. Now, they have found that there are ways you can reverse this later on. The people studying this are more interested in the mechanism here. I'm more interested in what is the point of this? Like, why did evolution set this up like this? So the proximal explanation is very important, of course, and they're working on the mechanisms there, and it's very complicated. The ultimate explanation, though, is how does this serve survival? Okay, so essentially what's going on, though, here is, and it's an example of phenotypic plasticity, where the genome will take an environmental variable, usually it's very specific and very simple, and use it as a cue to change the way that the genome is expressed subsequently, because it assists in survival. Now, what might that be here in this case? In this case, if the rat mother is able to devote the time and attention to licking the pups and paying extra mothering, then that is a signal that the rat pup picks up that says the environment that I'm in right now is safer. I can explore it with less danger. I don't have to be as sensitive to fear stimuli, because those variables are it's very big cost ratio here. Like, if I don't explore, I might not get the things that I need, but if I explore too freely, I might get snarfed up by a predator. So there's this very fine balance in behavioral tendencies that is being addressed right here with this cue that the rat pup picks up right out of the box, as it were. And this behavior is analogous in humans as well. There's the same neurotransmitters and mechanisms, apparently. They use childhood maltreatment as a stand-in for the maternal behavior. And there does seem to be very similar responses in human hippocampal regions, although it's, like I said, it's much more difficult to measure this kind of stuff in humans. But long story short, the people that study this sort of thing will definitely make a lot of parallels here and say, we think this is probably how it's working in humans as well. There are additional complexities here too, and it's not just about human fear response and exploratory behavior and so forth, but attachment formation patterns and things like that. It appears to be the case that childhood maltreatment leads to a cascade of epigenetic changes in the brain that are long-lasting. This is very important to therapists, for example, such as myself, psychiatrists, psychologists in general, because we want to know how this works and how to fix it, most importantly. Now, getting back to our nature versus nurture thing, here's my question for you. The rat pup gets a piece of environmental information from the mother, which has these long-standing consequences that have survival implications. Is that learning, though? I mean, technically, I guess you're learning. The thing is, the rat pup has no idea of the context or the ultimate meaning or the long-term downstream effects on survival. All of that stuff is set up beforehand by the genome. So yes, the psychosocial information is influencing the way the genome is behaving. But guess what decides how and why and to what degree? The genome does that all. The genome sets up when Do I look for this particular environmental cue at what point in my development in this very specific window, for example, in some cases? And then what are the consequences of that? It's not that they sit there and they think, oh gosh, mom is having a rough time, therefore I must be careful. No, this is all basically set up by the brain. And the genome is basically doing this because of the rat's species history, not the individual rat's personal history. So this is the thing I'm always getting into with debates about archetypes, is that there are responses in humans to specific environmental situations that I think are more likely due to our genomic and ancestral history as Homo sapiens, and have a whole lot less to do with our own personal idiosyncratic history. Psychology, though, traditionally has attributed absolutely everything to our own personal individual history, as if the entire psyche, as Jung once complained, was invented on the spot out of, with each individual person being born. That's not really how it works. We carry a whole host of these automatic if-then statements built into the genome that do this kind of stuff. And so that response that the rat and or the human is having to their environment is there because it most likely served survival over long periods of time. So bottom line here, okay, long story short, if someone comes at you with this, is it nature or is it nurture? Just shoot them with facts. Just because social variables affect the genome and the gene expression, I should be specific about that, they don't change the genome. Nothing changes the genome unless it's a mutation, and that's bad. It changes genome expression, very important. But just because a social variable, psychosocial variable, can affect genome expression does not mean it's not biological, all right? That's oftentimes what people seem to think it means. Actually, yeah, it is biological. The whole bloody thing is biological and environmental, right? It's just like Hebb pointed out. You can't look at the area of a square without asking what's the width and the length. Neither one of them is more important, right? It's a nonsense question. The specific cue, the specific response, the context, the ultimate evolutionary aim, all of that stuff is set up. And the only thing the genome needs is a piece of environmental information to help it decide which way to go. All this is in advance. Now, is it that simple in humans? In every case, of course not. There are many, many pieces of information that the human brain picks up in the psychosocial surroundings in order to then decide which way to go. And of course, the conscious ego does have free will and can play a part in this whole process. But there's a whole lot of stuff going on in the non-ego conscious realm that is more related to this kind of genomic response. And that's all I'm really wanting to make sure that you are aware of here, that this nature versus nurture business, we need to just let it go. All right, it's dead. Stop, please. Okay. So that's what I got for you today. I hope you enjoyed that Mysteries of the Psyche mini rant. Go ahead and check out ericgoodwyn.com, get on my newsletter, get all the updates on what I'm doing. I got lots of cool stuff for you this year. This is going to be our year. It's going to be awesome. And yeah, like, share, all that kind of jazz. And I'll see you next time.